Alright, this is my rotational kinematics problem, and in this, a truck is starting from rest at a red light, and it's speeding up to get on the interstate. So when the truck's speeding up, the flywheel is spinning at 4,800 RPMs, revolutions per minute. If it takes the flywheel on the truck 2.6 seconds to reach this angular velocity, what is the angular acceleration of the flywheel in radians per second squared? And so that's one question we're asking. The other question is, how many rotations did the flywheel make while speeding up? So to start, I went ahead and wrote down my angular velocity from the beginning is 0 because it's starting at rest. The angular velocity final is 4,800 revolutions per minute. So since we need to find radians per second, we're going to do this equation where you multiply the 4,800 times the 2 pi radians, because 2 pi radians equals 1 revolution. So then from there, you're going to divide by 60 seconds to get the seconds instead of minutes. And I got 503 radians per second. So, and then the time that it took was 2.6 seconds. So we take the time to find the angular acceleration. Here is the change in the angular velocity over the change in time. So the change in angular velocity is the 503 radians per second, which is the final minus the initial, which is 0. So it's just going to be the 503 radians per second divided by 2.6 seconds, which gives you 193 radians per second squared. So that is the angular acceleration for the flywheel. And then to find the amount of rotations that it took, you're going to take this equation here, which is the second angle. I'm sorry, not second angle. It is the rotations that it took. So how many times it spun around, which equals the angle of the beginning, which is nothing, plus the average angular velocity, which is also 0 because it's starting from rest, multiplied by the time. And since these are both 0, we'll bring this down here. So the theta 2 equals 1/2 times the 193, which we found here, which is the angular acceleration, multiplied times your time squared. So whenever you do that, you get, I got 652.34 radians. And so to find the revolutions, you're going to multiply times 1 revolution divided by 2 pi to get it into revolutions, which then that divided by 2 pi is 104 revolutions.